In this video, we're going to see how to connect business process instances performed in Camunda with the data processing performed in WSO2. Here you see that I already opened the Camunda modeler tool and I modeled a small process which starts with a start event followed by two activities and then an event-based gateways which remains waiting for the first of these two messages to arrive. When one of these messages is arrived, then corresponding activity is followed, and that would terminate the process. So let's first decorate these tasks with their type. In particular, we want the very first task that I called just set amount to be a user task, meaning that in this task we're going to ask the user to fill a form with a certain input. To do that, I changed the type of the task here, and then it is necessary to open the property panels and go to the form tab in order to add a new field. So it's possible to click on the plus sign in here, and let's set as ID set amount with type long, and as label we could set something like set amount, and as default value we can insert 0. Okay, so now we set the form for the first activity, and in addition we want to set the two last activities that this process can finish with as user tasks as well. So in this way we know which activity will be triggered. That's because the user will need to claim the corresponding activity in order to complete it. Then we have the second activity is actually call service. It is called call service activity, and in this activity we want to send, we want to trigger an external service with a REST call, which should include the amount set in the previous activity. So to do that, we need to first change the type of the activity to a service task, and then we have to open the properties panel, and as implementation we need to set an external connector. Then the modeler is informing us that we need to configure such connector via the connector tab. So here we can set as connector ID HTTP connector, which basically indicates that this service will be called via an HTTP connection. And then we need to set the parameters for such connection. To do that, we can use the plus button next to the input parameters box, and we need to set 4 of such parameters. The first parameter has to be the URL, so we can set it as URL, and as value let's temporarily set HTTP localhost port 8081 / Camunda stream. So this is where this is the end point of our connection, so where all the connections will be forwarded to. Then we need to set the method type for our connection. So we need to set as parameter name method and value post. And then we need to set the headers of the connection, of the HTTP connection, and we can do that by setting the type of the parameter to map and adding one entry with key, content type, and value application JSON. And finally, we can set the actual payload for our for the connection. To set such payload, we need to define the parameter, the input parameter payload, and as value for such parameter, we need to set the JSON representation of the payload itself, and we need first an attribute called amount. And here, as value for such attribute, we want to provide the value set on the previous activities. And we can do that with the Java expression language. So we can get the set amount value with the dollar symbol followed by the curly bracket with the name of the with the ID of the field from the previous activity. In addition to that, we want to set we want to provide to the event processing engine information about the ID of the current process instance. So we need to provide an instance ID attribute, and here as value we can use again the expressions by accessing the execution object, which is always available in Camunda, and we want to call the get process instance ID method on such object. So execution dot get process instance ID. Now we can save our process with Ctrl S or the save icon in here, and we can deploy it by using the deploy button on top and select deploy current diagram. We can give a name to our deployment, for example demo, and we can deploy. And once we get that the deployment has been successfully completed, we can open the Camunda cockpit and check whether this is indeed whether the process has been deployed. So first we sign in with the default username and passwords, which are demo. And in here we can go to the cockpit and see that we have we can go to the deployments, but we see already that we have one process definition deployed. So when we open that, we see that the diagram associated to this deployment is indeed the model that we just created. In addition to that, I would like to suggest you to have a look at the Camunda documentation, and in particular under the user guide and process engine there is the process variables page that is very useful as input point for having information about the variables being set by the other tasks, and also about the expression language page here, which provides useful information about how to provide information, how to use information during the execution about the different variables being set. This expression language can be used in conjunction with the Camunda Java doc, and for example in the model that we designed before, we were accessing the execution object, and in particular we were calling the get process instance ID method in order to retrieve the ID of the current process instance. Now that we have our process deployed in Camunda, we can connect, we can consume the events being produced by the external service of the process in a Siddhi application. So to do that, we can open the Stream Processor Studio and create a new file. Let's call this Siddhi application Camunda stream. And the first thing we need to define is the stream that will receive the values from the form as well as the process instance ID. So let's define a stream called Camunda input stream with two values, amount and the instance ID, which is actually a string. We need to inform Siddhi that the events of this stream are actually coming from an HTTP connection, and we can do that by setting a source with type HTTP. In addition to that, we need to set the endpoint of the connection for these HTTP events, which has to be the same as we set in Camunda. So receiver.url equal to HTTP localhost port 8081 / Camunda stream. Finally, we need to set, we need to inform Siddhi about the type of the events that will be received, and in particular we need to use the map annotation, and we need to inform that the type of these events is going to be the JSON format, as we said in the header and on the payload in Camunda. Finally, we want to log all the events produced in this stream in the Stream Processor Studio, and we can do that by defining a new sync with type log for this stream. So sync with type log. We can now save this application, and we can start it with the button in Stream Processor Studio. So now the application is initialized, and as we read on the console, it is the Stream Processor Studio and the Siddhi application is now listening on this HTTP source for events. So if we now go back to Camunda, and in particular we go to the task list of Camunda, we can initialize a new process instance by clicking the Start Process button on the top bar. And so far we have only one process deployed, so we need to select this process and we can start. And now if we go to the All Tasks section, we see that we have the first activity of the process, which is set amount for this process instance. So we can click on the activity and we can claim the execution of this activity. So now we need to set the values for this for the form of this activity. In particular, we need to provide the amount, and let's say that we provide as amount the value 42. Then we complete the activity, and first of all, in Stream Processor Studio we see that a new event has been received, and since we have a sync associated to this stream, the event has also been logged with as list of attributes: the value 42, which is the value that we set in the Camunda form, as well as the process instance ID of the current process instance. Now if we go back to to the cockpit in Camunda, we see that we have one running process definition, one running process instance. So if we click in here, we see that this process instance is referring to process 1. And in particular, we see that this process instance completed the service task and is now waiting for an event to so it is the process instance is waiting on this event-based gateway for either message 1 or message 2. With the Siddhi application that we just defined, we are able to send events from Camunda to a Siddhi application. However, now what we want to do is to do some processing for these events, and we want to send messages back to Camunda. So if we check the model that we designed earlier, we see that once the service activity is completed, then the engine waits for either a message 1 or a message 2 to arrive before continuing with a new user task. So now in the Siddhi application, we need to do some processing of this event, and then we want to send back to Camunda either a message 1 or a message 2. So let's open our application again, and we need to first define so the strategy that we're going to use for sending messages to Camunda is to define a whole stream and associate such a stream with an HTTP sink, where we are going to set as URL of the publisher the REST API endpoint of the Camunda engine. So let's first define such stream. Let's call it message stream. And in this stream, we need to provide two information. The first is the process instance ID. So who's the recipient of which process instance is the recipient of the message, and the message itself. So process instance ID, which is a string, and the message name, which also is a string. And let's for the moment just add a comment to this stream. So set as sink the REST API of Camunda. So we want, as we said, we want to do some processing for the events that are coming in our Camunda input stream, and in particular we want to filter so for this application we want just to filter the executions for which the amount was above or below a certain threshold in order to set proper messages. So from the Camunda modeler, we see that the process engine expects two messages to be received. So let's write down two queries which are going to generate two messages. So the first query takes the values from the Camunda input stream and filters only the events with amount above the threshold 10. And for these events, we can select the instance ID as process instance ID, and we want to send the value message1 as message name, and we want to send this event into the message stream stream. Similar query, but with different different threshold and different message. So Camunda input stream, we want to filter all the events with amount lower or equal to 10. We select the instance ID from the source stream, but in the message stream this is actually called process instance ID, so we need to rename this attribute to process instance ID, and the name of the message has to be message2 as message name. And we want to insert this new event into the message stream. So now we need to set, what remains to do is to set the sync for the message stream in order to connect to Camunda. So by inspecting the Camunda documentation, there is in the reference section of the Camunda docs, there is an extensive description of all the possible REST interactions possible with the Camunda engine, and in particular in this case we are interested on the message interaction, and you see that the method to call is a post command to message, and you see here the list of parameters that are required, and we're going to use the message name as well as the process instance ID. So let's set the sync to sync type HTTP. Then we need to set the URL of the publisher, publisher.url, and this has to be the URL of the REST, where the REST method is actually located. So HTTP 127.0.0.1. The port of my Camunda engine is actually 8080 / engine rest / message, as we saw from the documentation. We need to set the proper headers for this connection with the headers parameter set to host 127.0.0.1 and the port, and that's in my case needed because I'm running everything within my local machine. And then we need to set actually the mapping of the event of this stream into the JSON format. So we can do that by using the map with type JSON, and then we can provide the payload, which takes the actual string as parameter, so the payload string, that in our case has to be the message name and here we can reference the actual event attribute with the double curly brackets, so message name between double curly brackets, and then we need to provide the process instance ID as well, so process instance ID, and again between double curly bracket we can refer to the event attribute, which in this case is process instance ID. It seems we have an error because we need to properly close the the JSON object first, and then close the triple double quotes of the payload, which should not have the single quote. Okay. Good. So we can now save the Siddhi application, and we can test it by starting the application itself. The application is started, and we can see that now the application is listening at the port 8081, and it is listening for events in this Camunda input stream. So now if we try to create a new process instance, setting the value to setting the value for amount to above 10, to a value above 10, then the CD application should generate back an event with message 1. Otherwise, because of this query, otherwise if we create a new instance and as value for the amount we set a value below or equal to 10, then message 2 should be generated and sent back to the Camunda execution. So let's now go back to the Camunda, and in particular to the task list, and let's now start a new process instance for our process 1. And now we need to set the amount. So let's set the amount to the value 42. And again, having a value 42 means that we're sending this value to the CD application, which will process it and should send back message 1 to the Camunda. So if we complete this application, then we see that in the old task what we need to execute is terminate A. So if we open the modeler again, you see that when message 1 is actually being sent, terminate A becomes enabled, so we need to execute terminate A. Let's now start another process instance with a value below 10. So we claim again the sent amount, and as value we send the value 3, for example. And once we complete this activity, we see that now we have terminate P that has been created, because back in the modeler, when we send to this service a value which is below 10, message 2 is actually being sent back to Camunda, and therefore we have a terminate B activity. Of course, these two activities are actually referring to two different process instances, as we can see from the cockpit. So if we go to cockpit, we see that we have two running process instances, and we see that one is actually waiting for the user task terminate A, and the other is waiting for terminate B. And all of that has been so the whole logic for which message to be sent around is actually encoded as a CD application, as this CD application, where we have two streams, one which is collecting events from Camunda, those demonstrating how to send events from Camunda to the to Stream Processor Studio, and then we have two queries which are actually processing all of these events by applying a filtering agent on the value of the amount attribute for those events, and based on the on this agent, events with different content are being generated for the second stream defined here, and this stream is actually associated to an HTTP sink, which is sending these events to the REST API of Camunda, constructed according to the specification of the Camunda documentation. This way, with this Siddhi application, we have two ways communication between Camunda and Stream Processing Studio.